This lesson is an overview of game management. And more properly, it should be called match management, as the issue is how to manage individual matches of games, not the games themselves. We start with an overview of the general game-playing ecosystem and the central role of the game manager. We then discuss the general game-playing communication protocol, and finally we see how it's used in a simple game. Here's a diagram of the typical general game-playing ecosystem. At the center is the game manager. The game manager maintains a database of game descriptions, it maintains some temporary state for matches while they're running, and it maintains a database of match results. The game manager communicates with game players using the Internet's TCP/IP protocol, and more specifically HTTP. It also provides a user interface for users who want to schedule matches, and it provides graphics for spectators watching matches in progress. In the current GGP communication language, there are 5 types of messages, which are used for communication between the game manager and the game players, namely info, start, play, stop, and abort. Let's look at each one of these in turn. An info message is used to confirm that a player is up and running. The general form is shown here. Upon receipt of an info message, a player is expected to return ready if it is ready to receive messages and play a game. Otherwise, it should return nil or busy. Of course, if a player is not running or not connected, there will be no response. So in practice, info messages sometimes evoke no reply at all. A start message is used to initialize a match. The general form of a start message is shown here. The message begins with the keyword start, and that's followed by 5 arguments, namely a match identifier. It's a sequence of alphanumeric characters beginning with a lowercase letter that uniquely distinguishes the match. There's a role for the player to play, chosen from among the roles mentioned in the game description. A list of game rules, written as sentences in prefix GDL. A start clock in seconds, and a play clock, also in seconds. Upon receipt of a start message, a player should prepare itself to play a match. Once it's done, it should reply ready to the game manager that it's ready to begin. The GGP protocol requires that the player reply before start clock seconds have elapsed. If the game manager has not received a reply by this time, it proceeds on the assumption that the player is ready. A play message is used to request an action from a player. The general forms of the play message are shown here. In each case, there's an identifier for the match. On the first request, where there's no preceding move, the second argument is nil. On all subsequent requests, the second argument is a list of the actions of all the players on the preceding step. The order of the actions in the record is the same as the order of the roles in the game description. Note that if a player fails to reply or does not reply in time, the manager substitutes a random legal action. Upon receipt of a play message, a player uses the move information to update its state as necessary. It then computes its next move and returns that as answer. The GGP protocol requires that the player reply before play clock seconds have elapsed. If the game manager has not received a reply by this time, or if it receives an illegal action, it substitutes an arbitrary legal action. A stop message is used to tell a player that a match has reached completion. General form is shown here. There's a match ID and a record of the actions of all the players on the preceding step. Upon receipt of a stop message, a player can clean up after playing the match. The move is sent along in case the player wants to know the actions that terminated the game. After finishing up, the player should return done. Finally, an abort message is used to tell players that a match is terminated abnormally. It differs from a stop message in that the match need not be in a terminal state. And upon receipt of an abort message, player can eliminate any data structures that it has set up and return to a ready state. And once it's finished, it should return done. Okay, so in summary, the process of running a match goes as follows. It begins with a receipt of a request to run a match from a human who wants to see the match run. The game manager may, at his discretion, send info messages to the players to ensure that they're ready to play. When it's ready, it sends a start message with appropriate arguments to each player to initiate the match. Once gameplay begins, the manager sends play messages to each player to get their plays, and it then simulates the results. This part of the process repeats until the game is over. The manager then sends a stop message to each player. Of course, if anything goes wrong, the manager may send an abort message at any time to terminate the match. Okay, now here's an example of messages for a quick game of tic-tac-toe. The game manager initiates the match here by sending a start message to all of the players, each with a different role. So player X is playing white and player Y is playing black. The players then respond with ready. They can respond immediately, or they can wait until the start clock is exhausted before responding. That's at their discretion. Play begins after all the players have responded to the start message, or after the start clock has expired, whichever comes first. In this case, the manager initiates play by sending a play message to all of the players. Since this is the first step and there are no previous moves, the move argument in the play message is nil. In this case, the first player responds with the action mark 1-1, one of its 9 legal actions, and the second player responds with no op, which is its only legal action. The game manager checks that all of these actions are legal, simulates their effects, and updates the state of the game for itself, and then sends play messages to the players to solicit their next actions. Second argument in the play message in this case is a list of actions received in response to the preceding play message. In this case, the first player responds with no op, its only legal action, and the second player responds with mark 1-2. It's not a particularly good choice. Again, the game manager checks legality, simulates the move and updates its state, and sends play messages requesting the player's next actions. The first player here takes advantage of the situation and plays mark 2-2, while the second player does no op. There's not much for the second player can do at this point to save itself. Instead of staving off its immediate loss, it plays mark 1-3, while the first player does no op. The game manager again simulates, updates, and requests a move. In this case, the first player goes in for the kill, playing mark 3-3. With this move, the game's over. As usual in such cases, the manager lets the players know by sending a suitable stop message, and then stores the results in the database for future reference, and terminates.